Hello. Welcome to our next episode of the YugabyteDB Community Open Hours.
Hello.
How's it going, Frank?
Good. And and it works on LinkedIn, and I think we also stream on Instagram if people can check and tell us in the chat. We have more and more channels there. Yeah, you can see it on Instagram. Yeah.
Yeah, I don't know how many technical folks are watching something on Instagram, but at least this format is very popular on TikTok. But our streaming platform doesn't support TikTok yet. Once it's done, we'll see. But if just in case, let's say you go to and check Instagram from time to time. Right now, you can also subscribe to our Instagram channel, where we from sometimes publish something related about the culture and the life at YugabyteDB, and also we will be experimenting with the streaming technology to that platform. Nevertheless, yes, thanks everyone who has joined us live. I see the folks joining from LinkedIn, from YouTube, from Twitter, etc. And just say hi. Tell us where you're joining us from and what's the reason for you coming here. So, Frank, where are you right now? It doesn't look like you are home. What's happening?
Yeah, I'm in London. That for once, it's not for a conference, but we did a tuning workshop with a customer. So I went to London for that.
Excellent. Yeah, someone needs to pay for the open source database, right? YugabyteDB is open source. Then you like YugabyteDB open source. Yeah, but still, like if you want to keep it running, and some people need to adapt an enterprise version of the technology.
And when you have a critical production on the database, it's always good to have support.
Mm-hmm. I just know I spent many years. I'm an Apache Software Foundation member, and that happened because I was contributing to another Apache project for a while. And as we know, like all of those Apache technologies, they're open source. Like Apache Kafka, Apache Hadoop, Apache Pulsar, Apache Cassandra, like you all know them, right? And they are free for everyone. But the success of those open source projects depend on the companies, on enterprise companies who are building them, because you need to have people who can spend their days and nights, contributing and developing those projects. So that's why, yeah, this is free for everyone, but still thanks a lot to all of those sponsors, customer sponsors who are sponsoring the development of open source technologies. Okay. All right. Any news, Frank? Yep, we see hi. Actually, wonderful. Right now, we received messages from LinkedIn into our streaming platform. I'm so excited because before that, folks, if you joined us, if that's not the first time you're joining us, like Pete, hi. Thanks for joining. Then usually what we would do, we would go to LinkedIn, we would copy comments from there, and then we would post them on our streaming platform, and that was a nightmare. So now everything is automated. And hi, Rickard. Thanks for joining. Yeah, in Sweden, wonderful. I've been to Sweden once. I've been to Stockholm. Wonderful trip. It was in early January. It was great. It was cold. It was chilly, but that was all right for me. I enjoyed the city. So, any news, Frank? Anything you'd like to discuss today? Anything on your mind? Because I have one. I have one highlight to share about anything from your end.
No, you can go. It's the things that are new are things that we will demo and talk about it. So yeah, go with your news.
We don't have any. As we had this quick conversation with Frank before we started the stream about the highlights, because it's still like January. It's quite slow, let's say, from the announcement perspective. But what happened before the end of 2023 is YugabyteDB was recognized as one of the top 20 leading databases by Gartner. If you know that company, that like technology analysts that basically analyzes the market of various technologies, and then they publish reports, and those reports are very important for the growth of different companies. And as Frank told me, hey, Denis, it's not a technical, like, why would we discuss this? But I said, like, no, it's not a technical update, but also that's an opportunity for two of us to say thanks to all of you who are using YugabyteDB, who are supporting YugabyteDB, who are talking about YugabyteDB, because that recognition would not be possible without the open source community, without the customers, without the users, because Gartner doesn't select just a random database for that magic quadrant. It needs to be adapted, it needs to be reliable, and it needs to be used right broadly. So thanks a lot to all of you. And so right now, YugabyteDB is one of the 20 top 20 cloud databases by Gartner, if to believe to Gartner. Okay. All right. So what's next? By the way, questions. Frank, let's remind our folks that everyone can ask questions because we always have a topic in mind for discussion. But if you want, if you have some question that bothers you or some problem, don't hesitate to open comments and ask us the question, and we will do our best to answer it during this live stream.
Actually, the topics that we pick are topics from questions that we got on Slack or on the forum. So it's all about questions from the community. But if there are live questions, that's of course the priority.
Mm-hmm. And this is why this live stream is called Community Open Hours. Sometimes we select some of the topics that are of our interest, but like with this one, I remember we met with Frank a week ago. Usually, like we have this bi-weekly cadence when we present. Then the next Monday we meet and we discuss what we would like to discuss next. And we did not come with any specific topics, but Frank said, "Hey, I'm actually with my heads down with this technical problem. There is a question from an open source user, like, why don't we discuss it?" And we came up with this doomsday scenario, how to prevent the doomsday with YugabyteDB, because this is like one of the reasons why folks select distributed SQL databases like YugabyteDB or others is like scalability. Scalability is not an obvious answer, but also you select distributed databases for high availability. And there are different ways how you can make your solution highly available. And that's why the doomsday. Let's talk about the doomsday. What does it mean, Frank? When you hear the doomsday scenario, what it can be?
It's something that should not happen. We don't expect it to happen. We protect from some failure, and doomsday is like there are a bit more failures than expected. Maybe because we didn't deploy the way that was needed to protect that. And basically, we protect the data with replication, and the most common deployment is replication factor 3, where there are 3 copies of the data, so that if one part of the cluster is not accessible, the other part still has the latest data because it has the majority. And then the doomsday is when you have lost a bit more than that, where what remains didn't get the quorum, didn't have the majority, and then doesn't know if all the latest writes are there. So basically the database cannot continue in this situation. You need to protect also for that. But there is still some data. And then the idea is, can we get most of the data out of it rather than just saying, oh, you have lost the majority, then you have lost your database. So there are solutions, but of course, those are not automated solutions, because in this situation, you have something that should not happen, and then the way to recover depends on understanding what really happened, what was down at which time, what was ongoing writing to the database at that time. So it requires a bit more manual interaction. Usually it's our support that does that, but for community users, free users, we do our best effort community support, and that was the case. We got the same week 2 users, one on Slack, one on the forum. With this situation, they started a cluster, probably the most, not the most critical ones, but one had a terabyte of data, and they didn't deploy correctly, or they didn't really understand was the quorum, and they have lost part of the cluster. And finally, they were able to get most of the data. I think all the data, but we cannot guarantee it because the majority is not there.
Yeah, let's do this. Yeah, that's you almost you have almost covered one of this, like one of the following topics that we have on the agenda. But that was a good example. That was a good example of Doomsday. For instance, if you take YugabyteDB, you would usually deploy like at a bare minimum. You want to deploy YugabyteDB with a replication factor of 3 across several servers, across several racks, zones, regions, or data centers. And you do this so that, let's say, if one of these availability zones or nodes goes down, you're not impacted. You will be operational because you have copy of the data, consistent copy of the data stored in other locations. But it can happen, like in Frank's example, the Doomsday is a scenario when you're losing the majority, meaning that if you have a 3-node cluster with replication factor 3 spanning across 3 zones or data centers, and then 2 data centers, boom, collapse, you lost the majority, right? So what do? So that's one of the example of Doomsday. So also, for me, if just how whenever I hear the Doomsday, it's like some really catastrophic event. It can be like due to some natural incidents, because sometimes we have hurricanes, blizzards, power can go down. You can have some major outage in a data center, and the data center can be just one of the availability zones of your cloud environment. This is like this kind of the Doomsday, and like you need to be prepared for it, especially if whether you run on your own infrastructure or whether you are renting this infrastructure for a public cloud from a public cloud provider. We have a question. Do you see this question? Let's share this question with everyone. We've got a question from Pete. I lost a master node or two. Masters don't fail over automatically to some other nodes, and the YB admin tool seems slightly complicated. So, Frank, what's happening? Like,
yeah, that's right. The difference is that the master must be known by all nodes. So it's possible to add a new one with YB admin, but you have to set the list and you have to inform all tablet servers that there is a new master. But the master is not in the critical path. And that's why I don't really like to call it the master. Even if the master is down, your application should be able to continue, because you can still select, insert, do your stuff there. What you cannot do when there is not this master that coordinates the cluster metadata, the rebalancing, the elasticity when you add a new node, this requires the master. So first, the master is not in the critical path. But yeah, that's something that we may improve, automatically create a new master. In that case, that's good feedback. Yeah. Usually you have multiple zones with many nodes in each zone, and then one master replica in each zone, and this one should be always there. Yeah. The main protection in the cloud, the failure that is the most common is network failure. Just an availability zone that is not accessible for a few seconds, minute, or hour. In that case, your application can continue until the master is accessible again. If it's really lost, like a data center burns, then yeah, currently you have to add and declare a new master. When I say you have, it can be our support on managed service.
why does why does remind me and those who are watching us, why does a T server need to know about the master? Because I understand like when the master needs to be know about all of the T servers, but why do we need to have this knowledge from the reverse direction, from T server to the master?
Because a T server doesn't have the whole picture about your objects in the database. A T server holds a few tablets, but if it has to run a stored procedure, if it has to do something on a table, then it needs to read the catalog, what is in Postgres in the catalog. But this is shared by all nodes. So this is in the master. Of course, each T server has a cache of it, but that means that if you do some DDL that change the structure of a table, for example, it's the master that is the point of truth of this. So the master is responsible for sharing this metadata. So if master is not accessible, your insert will continue, but your DDL cannot if the master is not there.
Mm-hmm. At least I will be able to read and write, but I will not be able to execute stored procedures. But what, let's say, if the server already cached that information about stored procedures and the master goes down, will I be able to execute a stored procedure? Do you know?
We can execute it because it's in a cache and nobody can
to drop it or to change it, right?
change the procedure, because if there is no master to send the change and then invalidate the cache on all T servers, then there is not. But the master is also resilient. There is a replica on each zone. So the problem is more like you have a master on in a data center that burns, and then you want to start a new master elsewhere, and it has a different IP because it's on a different network. This is where you have to run some YugabyTDB commands to define the new one.
And you just want to update every existing T server with the new master location. That's what
in the demo I've prepared, because of this Doomsday, we will recover from the loss of the master, but this is not the supported way. The supported way is really YugabyTDB adding new nodes.
Then let's get there first. All right. So, but moving forward. So hopefully right now, folks, it's clear to you what we assume under the Doomsday scenarios. It's like some major incidents due to some catastrophic events, human-made incidents, or natural incidents, when basically you are losing quorum of your cluster, or you're losing some data center, or you're losing availability zone, and you need to be ready. There are some of the basics when you're deploying a distributed database like YugabyteDB. There are some of the basics you need to keep in mind just to be ready for the Doomsday. First, as Frank said, you need to run at least with a replication factor of 3, correct? Because even if there is no any Doomsday, if there is no any major incident, still those nodes run on hardware. The hardware can fail, the network can glitch, and at least you need to have a 3-node replication factor of 3. Okay. Another one basic item is backups. It's like it belongs. That's a rule of thumb for every database. But Frank, you remember when we had this conversation with you? Let's say that I run YugabyteDB and I run, let's say, a 3-node cluster with a replication factor of 3, which means that even if I lose one of those nodes, I'm not losing the data. The data will be consistent, right? Because the copy is stored and updated using the RAV protocol on other nodes. Then why would I need to have backup? What are there?
That's for another kind of failure. So the replication is synchronous. If you drop a table, the most critical table in production, probably people should not connect to production and be able to drop a table. Everything should be tested before and automated. But if it happens, if you drop a table, then with the replication, we just replicate the drop, because that's the goal, having the same on all nodes. And then your table is gone. So for point-in-time recovery, you don't want resilience. You want to go back in the time, and then you want to go back to a backup or a snapshot from before. This is where you want it. The synchronous replication, the goal is to have the same data replicated everywhere to be resilient, but sometimes you want to go into the past.
Agree.
And that's the main
sometimes
reason
you want
for point-in-time recovery. But it's not an automated operation. It's something where you know what happened, and then you know what you need to restore. Probably you will not restore. I mean, dropping a table maybe, but imagine that you are doing an update and you forgot the where clause, and then you updated too much data. You don't want to restore it directly to production. You probably want to restore it to another cluster, and then look at the data, compare, and export, import what is you want to repair what was done manually. You have to repair it manually.
And this is I like this definition. You want to have backups because sometimes you need to go back in time. It's like back to the past. And this usually when like application updates, right, or anything that might happen. When I used to work as a software engineer, like daily, that was my day-to-day duty. Whenever we would release something like a new version of the application, even if that was a minor release, and we would test it, thoroughly, we still would create a backup first, because we knew that like this application once it goes down, it can get this production workload, and might be some slightly bug that can corrupt the data. The data will be corrupted not because like our database is poor, but because like there was some logic in the application that just removed some data or wrote down something wrong into the fields of a table. So that's why I have backups. And folks, if you have your own stories to share, like why do you want backups and how backups saved your lives and your sanity, just share with us. Let's see like what you experienced throughout your career as a DBA or as a developer. Curious to learn.
But the reason for distributed database is that you don't want to restore a backup just because the network is down, or just because one disk burns, or just for small infrastructure issues. You just want the database to be resilient, and this is why we have replication. Those are really two different kind of failures.
Okay, let's go to the demos, because we already discussed a lot. We already discussed this to death, the replication factor of 3, and this is the bare minimum. So how do you deploy? Like when you deploy your YugabyteDB cluster, let me see. I've got a comment from Yogi. I have one. I dropped full master table in my first deployment. Yeah, here you go. And this never happened to me, but yeah, I heard those stories, and that's why when I used to work as a software engineer, we started doing those backups, let's say, for every minor release. Not even talking about major releases. Yeah, this happens, folks. This happens. Going to the demo. Let me show you how to get in this. Some of you might have seen this demo many times, my friends, especially if you join us. But those who are new today, I just want to show you like the experience. For instance, you want to deploy YugabyteDB 3-node cluster with replication factor of 3, and you want to run it across multiple availability zones. Why across multiple availability zones? Because an availability zone is mapped to one of the physical data centers, and one of those data centers can go down. That's why if you want to prevent a doomsday scenario that can be caused by an outage in an availability zone, just deploy a 3-node YugabyteDB cluster across several availability zones. Okay, so how easy can we do this? First, I need to share the screen.
And that's easy in the cloud. Of course, on premises, if you have to build a new building and get electricity and cooling and all that, it takes more time. But with the cloud, it's very easy to have multiple availability zones and start VMs on multiple availability zones.
Exactly. So for now, I will just show you how to do this with your local laptop, because YugabyteDB is when you're in early development. When you are in early development, then let me do the entire screen. You still want to test stuff on your own laptop, and this is what I usually do. And YugabyteDB has a special tool called YugabyteD, and you use this tool. I think that we already blessed this tool for production. If not yet, then it should probably happen in the nearest future. So this tool is shipped with YugabyteDB distribution. For instance, I've already downloaded it on my machine. That's the latest version. I go to the bin folder, and let's say that my production deployment will be spanning across 3 availability zones in Google Cloud Platform. So and now I'm building this application, and I want just to simulate this cluster on my local machine. I can run this cluster sort of across availability zone with this configuration. How do I do this? We have this YugabyteD, and then you have the start command. And then you're saying that, all right, my first node will be listening on the following IP address. And then the other configurations are, that's going to be my base dir. This is where the YugabyteDB node will be keeping data and different logs and configuration, and the cloud location. You can specify your cloud location. When you're using YugabyteDB managed, That's our managed version. Then this cloud location will be set automatically for you. It's all easy. But if, let's say, you prefer self-hosted environment, if you would like to manage and deploy YugabyteDB on your own, then you can just easily configure this location by specifying this cloud location parameter. So here it's said that my node is going to be deployed in this cloud, in GCP, Google Cloud Platform. Then it will be deployed in the United States East 4 region, Northern Virginia, and then this node will be running in zone 1, okay? And that's my first node of the cluster. It says that, okay, I think that I messed up here. Let's change this. Advertise, let's check the spelling. What's wrong here? Advertise address. I think that what we need to do is YugabyteD.
It's advertise address, not advertise node.
All right. Start, stop, start. Okay, advertise address. Okay, let's change it. That's how you solve it. And then, oh, finally, spelling. That's what happens when you are not a native speaker. Just find the help command, and luckily, yeah, I used this help for the first time, and the tool is intuitive.
My problem in advertise is S or Z. I never know.
Okay. All right. So now you see that this node is running right now the replication factor 3. So because the cluster can figure out this on its own, because you have one node running. Now, if I go to this address, that's the UI. It's also free. That's my node. And this node is running in this availability zone, the one that I specified in the configuration. After that, remember our deployment needs to run across multiple availability zones. All you need to do is to start the second node, and I will be deploying it on this IP address. And I will tell this second node to join my first node, and it runs on the following IP address. We just started it. Next, that's going to be the location of for the data and for the logs. And this node will be running in zone 2 because I want to have a database node in every data center, in every availability zone. Starting the second one. Okay, it's ready. And the last one is going to be listening on its own IP address. And its base dir will be as follows, and its zone will be zone 3.
And here, YugabyteD is doing all the stuff we mentioned before about adding new masters, the YB admin, add server, and all that. Here it's easy because YugabyteD does it.
Mm-hmm. Exactly.
You start one node that knows only one master, and then another node, and all nodes must know the two masters, and then a third, and it sets replication factor 3 when you have 3 nodes. Yeah.
Mm-hmm. Probably I will show you this later, because when you start YugabyteDB node, it's a multi-process entity, meaning that it might have, it always has a T server process, it always has a Postgres process, right? Because Postgres received the requests, and then also it might have the master, and here is we also starting the master. But also, folks, pay attention to this. You remember when I was starting the second node or the first node, the replication factor was set to 1. But now I started the last one, and the replication factor was changed to 3 by the tool. Which means that right now you have a 3-node cluster with replication factor 3 running across 3 availability zones. If I go in here to my UI, that's what we have. We have these 3 nodes, and here is we've got different zones, zone 1, zone 2, and zone 3. And now this is how you can prevent from a doomsday scenario when one of these availability zones goes down, because the changes, the data will be replicated across 3 zones, and it's very easy to start. Okay. If you want to do the same, but for these regions, all you need to do, like for your own testing and when you're deploying on your own in a cloud of your choice, here is you just need to change, let's say the first node will be running in the United States East, the second one in United States Central, and the last one is in United States West. You just need to change this parameter, okay? And then and then you can just run some extra command. Another option, those who like to run everything are in a fully managed fashion. Let me do this. For the fully managed fashion, you can use YugabyteDB managed. And as an option, I will show you how you can create a multi-region cluster there. Let me connect. That's my account.
And while you connect, maybe I can answer. We have a question from Pete.
Yeah, sure.
About the join option where we use IP addresses. You can put a host name, but internally it will be the IP address. I will check for the reason. I also think it would be easier to have the host name rather than the IP address, but there are probably some reason, some environment where we are not sure about the resolution. But that's something I will check. Probably we will talk about it in a future open hours.
Mm-hmm. Yeah,
but better ask the engineers for the real reason.
Okay. Then finishing with my demo, right? I showed you how to use YugabyteDB tool to start a cluster across multiple zones. And you can do this in your real cloud environment. Or another option is always we have YugabyteDB managed. Here is you go to the cluster, you can create this dedicated cluster. And when you select your cloud provider, you have this multi-region option. You can replicate across regions. You can select your resiliency factor, and then you select the different cloud locations, your regions, and then it's going to be deployed and replicated. And YugabyteDB managed will set all those configuration parameters for the nodes on its own. You just need to pick your desired location for your database nodes. Let me stop sharing the screen if you hope. Yeah, let's check the questions. We actually got update from Yogi. First, folks who reminding you that Yogi shared his story when once he dropped the full master table, and the backups were very helpful. But then, luckily, that never happened again since. And that happened back in 2004. So that's how we learn, right? That's how we learn in our life. We need to learn from our own mistakes. That's how we grow and live as humans. Next, hi, Christopher. Thanks for joining us, and we've got a question. How does YugabyteDB relate to YBadmin? I've gotten the impression that this is for testing. Is that correct? Frank, you want to take this question, or you want me to answer it?
Yeah, the first reason we did YugabyteDB was to make it easier to start. As you have seen, you don't have to think about how many masters I will deploy before you just join. For production, it's probably better to do the full setup, the full config. The idea is really for quick start. And how does it relate to YBadmin? YugabyteDB runs some YBadmin in behind. So basically, to do the same as what Denis did with 3 commands, you need a bit more when you don't use YugabyteDB. But of course, if you deploy on Kubernetes, then you have Helm chart that will start the YB servers and the YB masters. So the idea is really to make it easy to get it fast.
By the way, I've got a
proof of concept. For example, you have an application on Postgres, you want to test it on Yugabyte, you just want to spin up a cluster, and then you want to test the resilience, then you just start new nodes. As a developer advocate now, I'm working mostly in labs, and I use YugabyteDB. If there is a production to deploy, then probably you will need more options than what is available today with YugabyteDB, but we are adding more and more to YugabyteDB. Maybe yes. I can mention something else. For customers who have support, we have a database as a service solution. The idea of YugabyteDB was also to provide the same usability, the same user experience to open source user.
And I can show it. Are you talking about YugabyteDB Anywhere? Or yeah, I will show you.
Or YB managed, but yeah.
Yeah, YB managed is for those who want to have this fully managed experience. But if you just want also to automate, upgrade, maintain your YugabyteDB deployment in the simplest way possible, and whether you're running in a cloud environment or your private data center, then we have YugabyteDB Anywhere. So that's like for self-manage. It also comes with UI, where you create your universes like clusters, and then you can easily, let's say, configure, update, and upgrade. Speaking about YugabyteD, actually, because my friend, remember, we keep discussing this tool frequently on our live streams, and historically we would always say that it's still not for production, but I went to their latest documentation and it said that you can use YugabyteDB for production starting this version. So it looks like the product management team blessed it, and folks, give it a try. So, and if you unfortunately come across any issues, just please report it as quick as possible, because as Frank said, our goal is to make this your primary tool for the deployment of YugabyteDB servers and masters, because it's so much simpler. You just seen this. So another question a follow-up question from Christopher. Is the YugabyteDB UI coming to YB-admin, so to speak? I can say that I have not heard about these plans yet. So right now, YugabyteDB UI, Christopher is talking about this UI, right?
Yeah,
so
this
right
one
now
is started by YugabyteD. It's another Java process. And the idea of YugabyteD is that we have one command and one daemon that can start others. So it is started automatically by YugabyteD. It is different from YB-admin. The goal is really to have a UI and maybe not the same functions in all. YB-admin is really to do something DBA like. The UI is the same as you can see in the managed service.
So at least this is for now. How it's gonna be evolving in the future, we'll see. But keep using it, and please keep sharing your feedback. Okay, and this will help us to decide what to improve and in what direction should we improve for YugabyteDB UI and other tool set that is free for everyone, because this is all free. You don't need to pay a penny, folks. It's all open source. It's open. Now, my friend, let's quickly go to the other Doomsday scenario. I deployed my 3-node cluster across 3 availability zones, right? I have it running here, and I have the replication factor 3. And I can lose at least one node at a time, one availability zone at a time. But then an unexpected happened. Another Doomsday scenario came alive. I lost 2 data centers. Usually it should not happen, but it happened. And how I can reproduce it easily. Let's say I go to, let me do this. I go back to my terminal window, and here is I have YugabyteD command. I want to destroy, not just stop, I want to destroy the node that is located under this directory. Node number 3 is destroyed, and node number 2 is destroyed. So which means that what's left? I have only, probably I have just one node left, but this node just needs to update this UI. I should be able to connect to the cluster though. Let me see, because I have the first node running. Probably the UI needs to be updated, but let's see what's happening inside. No, something, looks like I destroyed it well. But I know that I still have one node running. This node is YugabyteD status. Let me see YugabyteD status. This is a Doomsday. I lost the quorum. And node 1 is alive, right? Yeah, I don't know why it's not responding, but something, I need to check the logs on my Mac.
Because it tries to check something on the master, and the master is also in the same situation.
Anyway, that's a good remark. But nevertheless, at least we know that this data center where this node is running is available, right? And we have the data there. So how can we restore? For instance, we want to, while we are restoring those 2 data centers, we want to enable read requests, right? So we want to downgrade this cluster to replication factor of 1. And this is actually, Frank, what you were dealing with the last week. Let me hand over the screen to you, because you can show the more advanced demo.
So basically, I did the same while you were doing it, starting 3 nodes in Docker, and I tested with pgbench. So here I have a simple 3 nodes cluster, as yours, 3 nodes, replication factor 3. If I look at a table, it has tablets on the nodes with leader, followers, and 3 replicas. And then I will do something similar to what you did. Because I'm on Docker, let's say I disconnect the network for 2 nodes, YB1, YB2, but I do more. I kill the process and I remove the data. So basically doing the same as you did with a destroy. And I'm probably in the same case where I cannot access the UI. So everything is down because the only node that can be accessed cannot locate a leader. The Raft group doesn't have the quorum and then cannot work. So what we did, so we had 2 users in this case. They were experimenting with Yugabyte, and they really have lost the data. If it's only a server, you can mount the file system to another node and start it if it's an external volume, for example. But here it is completely lost. So when this happened, I didn't really know how to do, but I didn't want to say to a user, okay, you have lost terabytes of data, especially when you know that one node is still there and there is a high probability that most data is there. So then I asked to the colleagues in support, what would they do in this case if they have to support a customer with that? And we have some options that we have not published. Our support published a lot of notes to help user, but this one was not published because it can be unsafe if not used correctly. So for the moment, we prefer not to publish. I will show it, but the idea is that you never have to use that if you need this kind of disaster recovery, then there are other solutions to replicate to other places. So basically, in this situation, let me connect to the only container that remains, the YB 0. I'm there, and I will run. Let me just check. I will run quickly a script that generates a lot of things. So this script is using some YB, not YB admin, more YB TS CLI that connects to the T servers. So only one remaining, get some information, and I have a awk script to list the tablet and generate the magic command that you should never use. When you see a command that starts with unsafe, it's probably not good to try it yourself. I tried it in the lab, and this is a lab. And before giving those commands to the users, I really discuss with the support what can be wrong or not. So basically, what you can see with this command is that it mentioned the tablet server, so not even the master, and it connects to the ones that are available. Only one here because I have only one node, and this is the ID of the tablet that is gathered, same ID that you can see in the UI. And this unsafe config changes the config of the Raft group. The Raft group expects 3 nodes because it's replication factor 3. And here, I have only one replica, and I will say, okay, let's downgrade that to a replication factor 1. Okay, I know that I may have lost the latest writes because I have only one replica that didn't get the majority, but at least there is some data, and let's downgrade that to a RF1 so that I can continue. So basically, it says for this tablet, there is only one replica, and then it's replication factor 1. And you can see this special tablet that connects to the master, different ports. And it does the same for the master. In the master, there is one tablet with the catalog and all that. So I will run those commands, or maybe I will run only the one on the master. And we will see what we have there. So magically, this comes back. It still says replication factor 3 because that's the configuration I expect, but it runs with a single leader because this one is actually in replication factor 1. And if I look at the tablet server, so 2 are dead. And here I have 12 replicas, 12 tablet peers, so replicas, and only 4 leaders. So of course, I cannot access the data there, but I will do the same, downgrade to replication factor 1. So I will run, I can run all those, will be easier. So this reconfigures all the existing replicas that have no quorum. They are reconfigured as replication factor 1, exactly as if I had only a one node cluster. So I repeat it. I may have lost the latest writes that may have gone to the 2 nodes that are not available. So you may have lost a few transactions. But here you can see quickly that I have 12 tablets with 12 leaders. So just because it defines all as a leader, if I take one of the tables, each tablet has only one replica. That is a leader because it is a replication factor 1.
Like it.
And it says that
This is
the
dark
cluster
magic.
load
This
is
is dark magic
balanced.
that you just keep in mind, in case.
Hmm?
I mean, like this is a dark magic style solution. If everything fails, if the unexpected knocked your door, but still. And by the way, like yes, while I interrupted you, we experienced some issues with the LinkedIn streaming. It's like we're still streaming, but for some reason the LinkedIn no longer responding. It said that their stream has ended here. I don't know what's happening. Something broke. I see that Pete joined us on YouTube. So folks, if you I'm not sure we will be able to fix it, and we are running out of time, but I posted a comment on LinkedIn, and if there is any chance you're watching us, just join us on YouTube. YouTube is much more resilient.
I have LinkedIn open on another screen, and I think it works, but maybe
works?
it lags. I don't know exactly.
Yes, I don't know. Like, yes, sometimes when I update, I see like the latest video, but when I try to join, it just breaks and
Yeah, okay,
returns.
yeah.
I'm not sure like where the problem is. The problem might be on the StreamYard end or LinkedIn end, but at least everything here is streaming. We are live everywhere except on LinkedIn. All right.
I stopped only the Yugabyte containers and not the LinkedIn one.
I don't know. All right, so let's see. Let's
Okay.
yeah,
Then
let's get
the
back.
most important here. So here I am replication factor 1. So I can run something like, for example, pgbench to work. Yeah, I'm in the Docker container. So let me just run that. Or maybe it doesn't if it has to. Oh no, I've run. Okay. So yeah, what I was saying is that some operations may work, but of course, it's not the correct situation. If you create a new table, it will try to get 3 replicas and then say that it cannot. So here, pgbench was working, but if I run, let's say, sorry, if I start YSQL on YB0.
Okay, well, you're fixing here, Christopher
Yeah.
said
No,
that everything works well on LinkedIn in Stockholm. Whew, good to know. At least it failed for me. It might be a region level outage. If it works for you, Christopher, and for you, Frank, then there might be some outage in the United States East 4 region, because I am on the United States East, and
maybe,
I see the latest kind of last chunks of the video on LinkedIn, but it said no, it's done. Anyway, at least it works somewhere.
So here in my cluster, pgbench works, but if I want to create a new table, it tries to create it in replication factor 3, and I don't have enough nodes, so it tells me that it's wrong. So my cluster is still not okay. I forced replication factor 1 for the existing tablets, but the cluster still expect more. So now let's say so if I want to continue from that, okay, I saved most of the data, but now I want to bring it back to replication factor 3. And for that, I can restart my node where I had just disconnected and dropped the storage, or I could start new ones and join it. But basically, because the cluster is still trying to get a replication factor 3, the load balancer will kick in when the nodes are detected. To get faster, I will even start new nodes. Maybe that will be easier. What I want to show is that everything will automatically get back to replication factor 3 when there are all nodes there. Let me just check if it started. No? Docker restart, YB1, okay. I will start another one. For example, YB3.
And while you're starting, let me answer the questions. Yeah, we have a question from Ricard. Do you recommend Docker setup for prod or only dev test? Whatever you want. No, I mean, like, people, it's okay to deploy YugabyteDB in Docker, and many deploy in Kubernetes for the orchestration. I think that even we internally might be deploying. I'm not 100% sure, but on YugabyteDB managed, we might be running something in Docker. The only one rule is that when you need to create a dedicated persistent volume for your data for the nodes in Docker. That's it. So up to you. No any discouragement. Whatever you want. Use Docker or just deploy on bare metal. And Harry answered this question. Harry says, Christopher, that was the question about YB admin. The question, let me show you folks the question first by Christopher. The question was, how does YugabyteD relate to YB admin? I've gotten the impression that this is for testing. Is that correct? And Harry clarified that YugabyteD uses YB admin under the covers. It's a wrapper over various YB processes. Yeah, like the YugabyteDB ecosystem has many tools that we created for. And why YugabyteD, it's a good point. It uses all of them internally just to make life
it's a
easier.
Python script. We will rewrite it probably to something else, but for the moment, Python is okay. So here, I restarted the nodes, and you can see that it starts to replicate on it. So it detected that the cluster is not balanced, and then automatically it creates new replicas. For example, you can see that this one has already a leader and followers. And sometimes you can see when it is bootstrapping new replicas, you can see learners. So basically, here, I just started the new nodes, and then they are all replicated with replication factor 3. I didn't change the configuration there because that's the default configuration. If there are new nodes, it's back to replication factor 3. And here, my cluster is the same as before this Doomsday. Maybe a few writes were lost, but if you have to do that, and this is what I recommended to our users, if you can do a PG dump, of course, for terabytes, it's more difficult. It's probably better to export all data and load it on a new clean cluster, because we used unsafe procedures just in case to continue production. Better to have a clean cluster, but of course depends on what you wanted to do. So basically, Here,
Okay, good.
we temporarily set the remaining replicas as replication factor 1 and then added new nodes. And that also worked for the master.
Okay, my friend. All right. So this is, and as Frank said, this is just for the doomsday, like something that should never happen. Because what we did, we deployed a cluster with replication factor of 3 across several availability zones or regions, which means that we were ready to survive zone level or region level outages. But then, 2 zones went down, or 2 regions went down, and this is, and what Frank showed you is like your last resort, how you can get operational as by downgrade.
Yeah, let me just give a precision. When we say went down, in this case, we have lost the storage. If it were only the instances, then probably you don't want to do that. You just want to start a new instance on the block storage. Because if you deploy, for example, in the cloud in AWS, your data is not in local ephemeral storage. So even if the VM is down, you still have the EBS volume with data. So this is really when you have lost the data. To simulate it, I really deleted the file system.
Good point. Yeah, good point. And now let's say that if we want to prevent this from happening when you lost the quorum, what are the options? One of the options I have in mind is that you can deploy with replication factor of 5.
Yeah.
Right? But that will let you to survive how many, like two outages at a time, like you deploy. But it can come costly from the latency standpoint, because you would need to wait for the quorum from how many, from 3 nodes, right, before you can complete a transaction. What are the other options? For instance, what's about asynchronous replication? Because you can deploy, right, standalone clusters and have asynchronous replication. What are your thoughts on this?
Because in this case, this unsafe procedure, I mentioned that we may have lost the latest writes. So if you want a disaster recovery for this kind of thing, it is better that you use the normal deployment for asynchronous replication, where you may lose a bit of data, but you have everything that is replicated to another place in a safe way. And that's the cross-cluster that we have.
Yeah, but and let me also clarify for the folks. When you're saying that's safe, meaning that even when we had this configuration with a standalone cluster, synchronous replication draft, when you are losing those last updates, you're just losing those last transactions, but your data remains consistent, correct? For instance, if you're moving money from one account to another, right, and then you lost quorum, it means that the 2 accounts the transaction will be reverted on 2 accounts, right? It's the data will be in consistent state.
Not with my unsafe procedure, but with the cross cluster. Yes, that's the big difference. Here I did everything at tablet level.
All right.
And the status of the transaction status is in the transaction tablet. So if I have bad luck and then I restore the transaction tablet without data loss, but another table with data loss, or between foreign keys, then it can be inconsistent. And this is why it's much better to do a PG dump and then import it again, and then everything will be checked at least.
Okay. Good.
And that's the reason we have another solution for asynchronous replication, where we guarantee the transactions on the other side.
Yeah, with asynchronous replication, and also those we briefly discussed YugabyteDB Anywhere today. That's our version. That's management and monitoring, like control panel that helps you to easily self-manage YugabyteDB clusters. And soon, you have already announced it, and soon we will make available a feature when you just go to the UI, you set up your primary cluster, like secondary cluster in other region. Then the changes will be replicated asynchronously with transactional consistency guarantees. And then let's say if the doomsday happens, you are losing one of those data centers somewhere, you can go back to a YugabyteDB Anywhere, you just click some UI buttons and your secondary data center will be operational. And you will see the statistics, you will see how much of the data lag you had before that incident, meaning that would help you to understand how much of a potential data loss you might have, right? Something that was not replicated from the failed data center.
Yeah,
So like
and you
it's
can inform the user, check the latest transaction because we had a Doomsday. And something important also to mention, one common use case for this cross-cluster replication is the two data centers. In the cloud, it's easy to have three zones, three data centers, and then to have the quorum. But when you have only two data centers on premises, you cannot have a quorum between the two. So if you put two followers in one and the leader in the other, then there are some cases where it cannot just continue because you have lost the quorum. With cross-cluster, what you do in this case, you have two clusters, so they are resilient to node failure within the data center. And for the case where the data center burns, then you have a consistent replica, maybe lagging for milliseconds of the latest transaction, but at least you have a consistent replica on the other data center. So for two data centers, this solution is kind of the right solution to protect for disaster recovery in the data center, because you cannot have the quorum, it cannot be synchronous. Also, with two data centers, you don't want it to be synchronous, because if it's synchronous and you have a network problem between the two, then the database will stop. And okay, you want to protect the database, but you don't want to reduce the availability and stop the database when the network is down. So that's the solution for two data centers.
All right, good. And also you've got a Pete's kind of thought of wisdom, right? The risk of your unsafe tricks that you showed us, Frank, is that only individual relations will be consistent, but the related items, tables, indexes may be out of sync, hence possible corruption.
Exactly. All the operations I've done are at tablet level. So there is nothing to check that there is consistency between tables. To check this consistency, you need more. You need to look at the transaction table, and that's what cross-cluster does. Yeah.
All right. That was a lengthy, but I hope productive conversation for all of you who watched us live today and who will be watching us on demand later. What I want to, and we are already over an hour, but let's see, like if you folks have extra questions, we can stay here for 5 minutes and get them answered. But in the meantime, I just want to finish on a positive note. Let all those doomsday never happen to all of us. We never want to deal with all of those outages. Let them be zone level, region level, or something else. But still, we have to be ready, right? We have to be ready because we don't want to. Because if you are not prepared, you can lose your customer data. And eventually you can your company can get out of business. And that happened also. If you Google for many situations when something get lost, some data get corrupted, many companies get out of business. That's why let it be that never any doomsday will happen, but we need to be ready just in case.
So everything should be covered by a disaster recovery plan. It is okay if a disaster recovery plan says, in this case, we accept 3 hours of downtime and losing 1 hour of transaction. It is okay if it's validated by the business. If you want lower, then you have a deployment that may cost a bit more, but that has a solution. But ideally, every situation must fit in your disaster recovery plan. Also, because in this case, there are probably many other problems. I mean, if there is a fire in a data center, of course, it's bad for your data, but maybe you have also people in the data center. So there are more important things to think about. So ideally, about the data, everything should be automated if possible. And if it's not possible, the manual decision, the human decision must be easy, like just check, we accept this data loss. That was accepted by the business. Then we just fail over to the other one.
I like this conclusion. And it basically tells us, even though we are technical nerds, right? DBAs, developers, architects, we are responsible for their IT, for the infrastructure, for the operations, right? Of something that runs company's business. But whenever you are coming up with your high availability SLAs or you're coming up with your disaster recovery strategy, it has to be validated with the business, because it will be written on paper, and sometimes it will probably help you to come up with a simple version of your of your disaster recovery plan, because some of the folks might not allow any downtimes at all, meaning that their recovery time objective has to be within I don't know, like 10 seconds, right? Which means that they are not allow any data losses, which means that they might need to deploy a stretched cluster across regions and blah blah blah. But some other companies might be all right, like they might have this data lag, as you said, Frank, right? But and that's why you might want to deploy just X cluster asynchronous replication across various data centers, and you will be safe to do that because it's written in your disaster recovery plan and your high availability SLAs, and the business side of your company, put a signature, meaning that everyone is good. That was in agreement.
And also there is a cost, of course. If day one no data loss, it has a cost.
Exactly. All right, we don't have any questions yet, but thanks everyone who joined us today. Thanks to Pete, to Christopher, to Rickard, to Harry, and everyone else who joined the conversation virtually today, and certainly to Yogi. So, and see you folks next time. And if you have any suggestions on what should be discussed next in our next live stream, then just go to Slack channel and send us a note there. Bye-bye.
And I take the point about the YB master, the new YB master, and the IP addresses. We will check the technical reasons, and we can discuss about that also. Yeah.
All right. That's on you. All right. Bye-bye, everyone. Enjoy the rest of your day.
Bye.